Implementation of BYD's blade battery technology by 2024, for critical phases and a $1.2 billion investment in R&D.
Introduction.
BYD, one of the leading electric vehicle EV manufacturers globally, has announced an ambitious plan to implement its innovative blade battery technology by 2024. This initiative is supported by a significant investment of $1.2 billion in research and development R&D. The blade battery aims to enhance safety standards in the EV sector, addressing some of the critical concerns associated with traditional battery technologies. This report outlines the key features of the blade battery, the critical phases of its implementation, and the investment strategy that underscores BYD's commitment to this transformative technology.
Key features of the blade battery. 1. Safety innovations. Safety remains a paramount concern for electric vehicle manufacturers.
And BYD's blade battery is designed with several innovative safety features.
Significant advancements include nail penetration test. The blade battery has successfully passed rigorous nail penetration tests which evaluate the risk of thermal runaway, a critical safety concern for EV batteries.
Notably, the blade battery showed no smoke or fire during these tests, with surface temperatures remaining between 30 to 60 degrees Celsius, in stark contrast to traditional ternary lithium batteries that can exceed 500 degrees Celsius and catch fire. Thermal stability. The blade battery offers enhanced thermal and chemical stability characterized by a higher starting temperature for exothermic reactions and reduced heat generation during operation. This reduces the likelihood of battery failure and enhances the overall safety of the vehicle. 2. Structural efficiency. The blade battery features an innovative design that maximizes space utilization. The batteries consist of singular cells arranged in a compact array, resulting in more than 50% improvement in space efficiency compared to conventional lithium iron phosphate LFP block batteries. This structural optimization not only boosts battery performance but also contributes to improved vehicle design and aerodynamics. 3. Market positioning. BYD's blade battery technology is poised to reshape the EV market landscape. The company is open to collaborating with other vehicle manufacturers to share this technology, indicating a strategic move to foster partnerships and enhance industry safety standards collectively. The flagship model, the Han EV, is set to introduce this technology, featuring impressive specifications such as a range of 605 km and rapid acceleration from 0 to 100 km per hour in just 3.9 seconds. Critical phases for implementation. BYD's strategic rollout of the blade battery technology is structured into 4 critical phases, each essential for the successful integration of this advanced battery system into its EV lineup. Phase 1. Research and development. The first phase focuses on the refinement of blade battery technology. This includes extensive research into enhancing safety features, optimizing performance, and conducting rigorous testing to ensure that the battery meets the highest industry standards. BYD emphasizes the importance of safety and aims to set new benchmarks for battery technology. Phase 2. Production scaling. With the R&D phase underway, BYD plans to scale up production capabilities. This involves constructing new manufacturing facilities primarily in central China, which will enable the company to meet the anticipated increase in demand for EVs equipped with the blade battery. The investment will facilitate the establishment of production lines specifically designed for the blade battery. Phase 3. Testing and certification. Before mass production, the blade battery will undergo extensive testing under various conditions to validate its safety and efficiency. This phase is crucial for ensuring that the battery performs reliably in real-world scenarios. BYD is committed to transparency and rigorous testing protocols to instill confidence in consumers and industry stakeholders. Phase 4. Market launch. The final phase involves the integration of the blade battery into BYD's vehicle models, starting with the Han EV. The launch is expected to highlight the advantages of the Blade battery, showcasing its performance metrics and safety features. BYD's marketing strategy will emphasize the enhanced safety and efficiency of its new models, positioning them as leaders in the EV market. Investment and future outlook. The $1.2 billion investment in R&D underscores BYD's strategic focus on battery technology as a cornerstone of its business. This investment will not only support the development of the Blade battery but also position BYD to maintain a competitive edge in an increasingly crowded EV market. As competition intensifies, BYD aims to redefine industry benchmarks for battery safety and performance, shifting the focus back to safety amid an industry trend that prioritizes energy density. BYD's investment reflects a broader understanding of the need for sustainable and safe battery technologies as concerns over battery safety continue to grow among consumers and regulators alike. By prioritizing safety innovations, BYD hopes to differentiate itself from competitors and establish its Blade battery as the standard for future electric vehicles. Conclusion: BYD's Blade battery technology represents a significant leap forward in electric vehicle battery design, setting new standards for safety, efficiency, and performance. The company's planned phases of development, from R&D to market launch, demonstrate a comprehensive approach to integrating this technology into its EV lineup. As the automotive industry navigates the transition to electric mobility, BYD's commitment to safety and innovation positions it as a key player in shaping the future of electric vehicles. The anticipated launch of the Han EV with the Blade battery will serve as a benchmark for future developments, highlighting the importance of balancing performance with safety in the rapidly evolving EV landscape. BYD's Blade battery not only addresses current market demands but also lays the groundwork for a safer and more sustainable future in electric transportation. 1. Counterintuitive safety focus. The Blade battery's emphasis on safety contrasts sharply with the industry's current obsession with maximizing energy density. While many manufacturers prioritize extending the driving range of electric vehicles' EVs, BYD is redirecting attention to safety as equally, if not more, important. This shift in focus challenges the prevailing industry narrative that higher energy density correlates directly with better performance. 2. Unexpected performance under stress. The Blade battery's performance during extreme tests such as nail penetration, crushing, and overheating reveals a counterintuitive resilience. While conventional batteries may catch fire or explode under similar conditions, the Blade battery demonstrated remarkable stability, emitting no smoke or fire. This challenges the assumption that all battery technologies are equally vulnerable to damage and raises questions about the reliability of widely used battery types. 3. Structural design efficiency. The design of the Blade battery, which allows for increased space utilization by over 50% compared to traditional designs, goes against the typical belief that larger batteries are inherently more efficient. Instead, the Blade battery's compact arrangement challenges the notion that size equates to performance, suggesting that innovative design can yield substantial benefits without necessarily increasing volume. 4. Market collaboration strategy. BYD's willingness to share its Blade battery technology with other vehicle brands represents a shift away from the competitive, proprietary strategies often seen in the tech and automotive industries. This counterintuitive approach indicates a recognition that collaboration may lead to broader industry advancements and potentially higher market adoption rates for safe battery technologies. 5. Investment in R&D amid market competition. The decision to invest $1.2 billion in R&D, particularly focused on a single technology amid fierce competition, may seem risky, especially when many firms are pursuing rapid market growth through diverse strategies. However, BYD's approach suggests a belief that establishing a safety benchmark through this significant investment can yield long-term competitive advantages, contrasting the short-term focus common in the EV sector. 6. Performance versus safety trade-off reassessed. The Blade battery's ability to maintain safety without sacrificing performance, e.g., cruising ranges and acceleration, challenges the narrative that one must compromise safety for performance in EVs. This positions BYD to potentially redefine what consumers expect from EV batteries, paving the way for a future where safety and performance coexist harmoniously. 7. Thermal stability misconceptions. Many assume that higher temperatures in battery operation are a sign of better performance. However, the Blade battery's thermal management, which features a higher starting temperature for exothermic reactions and reduced heat generation, contradicts this assumption. It suggests that effective thermal stability is crucial for safety and efficiency, potentially leading to a re-evaluation of thermal performance standards in the industry. By addressing these counterintuitive aspects of BYD's Blade battery technology, the company not only challenges existing paradigms within the EV sector but also sets a new standard that may influence future developments in battery technology and electric vehicle design. The report on BYD's implementation of Blade battery technology provides significant insights into the future of electric vehicle EV safety and performance. While many aspects of this initiative are highlighted, certain critical details may be overlooked by the general audience, yet they carry substantial importance. 1. Safety innovations and industry standards. The Blade battery's design prioritizes safety through innovative engineering. The nail penetration test is one of the most rigorous assessments for battery safety, simulating a severe impact that could lead to thermal runaway. The Blade battery's performance, showing no smoke or fire in maintaining lower temperatures during this test, is a crucial detail that underscores a paradigm shift in battery safety standards. Significance: this safety breakthrough is not merely an enhancement for BYD's products but sets a new benchmark for the entire EV industry. The focus on safety may encourage competitors to prioritize similar innovations, potentially leading to a broader industry shift towards safer battery technologies. In an era where consumer concerns about EV safety are heightened, BYD's advancements could reshape public perception and trust in electric vehicles. 2. Structural efficiency and space utilization. The Blade battery's unique structural design allows for over 50% greater space utilization compared to conventional lithium iron phosphate batteries. This compact arrangement not only optimizes performance but also enhances the overall design of the vehicles that utilize this technology. Significance: the implications of improved space utilization extend beyond performance metrics. Greater efficiency in battery design can lead to lighter vehicles, enhanced range, and more innovative vehicle designs. This aspect may be underappreciated by those focused solely on energy output, but it represents a significant leap forward in how vehicles can be engineered to meet diverse consumer needs and preferences. 3. Collaborative market positioning. BYD's willingness to collaborate with other vehicle brands marks a strategic pivot in the competitive landscape of the EV market. The company is not just positioning itself as a manufacturer but also as a technology partner willing to share its advancements. Significance: this collaborative approach could foster innovation across the industry, allowing smaller manufacturers access to cutting-edge technology that can elevate their products. It signifies a shift from a competitive to a cooperative model in the EV sector, potentially accelerating the adoption of safer and more efficient battery technologies across a broader range of vehicles. This aspect may often be overlooked in discussions focused on individual company performance. 4. Investment in R&D as a strategic priority. The commitment of $1.2 billion to research and development emphasizes BYD's recognition of the competitive pressures in the EV market. This investment is aimed not only at scaling production but also at continuing to innovate and refine battery technology. Significance: this level of investment highlights the crucial role of R&D in maintaining market leadership and addressing the rapidly evolving consumer expectations for safety and performance. It signals to the market that BYD is serious about its long-term vision and is prepared to invest heavily to ensure that its technologies remain at the forefront. This may be overlooked by those who focus only on the immediate product offerings rather than the strategic foresight that drives long-term success. 5. Shifting focus from energy density to safety.
The report indicates a prevailing trend in the industry that emphasizes energy density at the expense of safety. BYD's Blade battery aims to redirect this focus back to safety, indicating a critical industry-wide need for balance between energy output and user safety. Significance: this shift is vital as it addresses a fundamental concern for consumers and regulators alike. By prioritizing safety, BYD not only enhances its product appeal but also positions itself as a leader willing to challenge the status quo. The potential long-term impacts of this shift could lead to regulations and standards that favor safer technologies, influencing the entire market direction. Conclusion: BYD's implementation of Blade battery technology is a multifaceted initiative that encompasses safety innovation, structural efficiencies, collaborative market strategies, and significant investments in R&D. Each of these components carries weighty implications for the future of the EV industry. By recognizing and understanding these overlooked details, stakeholders can appreciate the transformative potential of BYD's advancements and their broader impact on electric mobility. This initiative not only represents a technological leap but also a strategic pivot that could redefine industry standards and consumer expectations. 1. Safety innovations. BYD's Blade battery technology is a significant advancement in addressing safety concerns in electric vehicles (EVs). The battery has successfully undergone rigorous testing, including a nail penetration test, and has demonstrated superior thermal stability compared to traditional batteries. This focus on safety is critical in an industry where battery fires have raised consumer concerns. The Blade battery's ability to operate at considerably lower surface temperatures, 30 to 60 degrees Celsius, during extreme tests positions it as a safer alternative, potentially reshaping consumer confidence in EVs. 2. Structural efficiency. The unique design of the Blade battery, which arranges singular cells in a compact array, enhances space utilization by over 50%. This structural efficiency not only improves battery performance but allows for more innovative vehicle designs, leading to better overall performance and efficiency in the electric vehicle market. This aspect emphasizes the importance of integrating battery technology with vehicle design, which can influence the competitive landscape of the industry. 3. Investment in market positioning. BYD's substantial $1.2 billion investment in R&D signifies its commitment to advancing battery technology and maintaining a competitive edge in the rapidly growing EV market. The company's strategy to collaborate with other vehicle brands highlights its willingness to share technological advancements and foster industry-wide improvements. This collaborative approach may lead to broader adoption of the Blade battery, influencing market trends and standards across the sector. 4. Critical phases for implementation. The outline 4 critical phases for implementing the Blade battery technology: research and development, production, scaling, testing, and certification, and market launch, demonstrate a structured approach to innovation. Each phase is essential to ensure that the technology meets safety and performance expectations before entering the market. This methodical rollout not only mitigates risks associated with new technology but also ensures that BYD can effectively respond to increasing market demand for safer and more efficient EV solutions. 1. Tesla's Gigafactory development, 2014 to 2020. Tesla's ambitious plan to build the Gigafactory in Nevada was a pivotal moment in the electric vehicle EV industry. With a projected investment of $5 billion, the Gigafactory aimed to significantly scale up lithium-ion battery production to meet the surging demand for Tesla vehicles. The factory was designed to produce enough batteries to power 500,000 electric vehicles annually, driving down costs through economies of scale and innovative manufacturing techniques. This initiative not only strengthened Tesla's position in the EV market but also influenced a global shift towards electric mobility, emphasizing the importance of battery technology in achieving sustainable transportation. 2. Toyota's hydrogen fuel cell development, 2002 to 2014. Toyota invested heavily in hydrogen fuel cell technology as part of its strategy to lead the automotive industry towards sustainable energy solutions.
The company's efforts culminated in the launch of the Toyota Mirai in 2014, one of the first commercially available hydrogen fuel cell vehicles.
Toyota's investment in R&D, which exceeded $1 billion over the years, focused on improving fuel cell efficiency, durability, and reducing costs.
This initiative underscored the potential of alternative energy sources in transportation.
Much like BYD's Blade battery aims to reshape the EV landscape with safer and more efficient battery technology.
3. General Motors Ultium Battery Platform 2020. General Motors unveiled its Ultium battery platform in 2020, committing $27 billion over the next few years to accelerate its electric vehicle strategy. The Ultium platform is designed to power a wide range of vehicles from mass market to high-performance models and emphasizes flexibility in battery chemistry, size, and configuration.
This modular approach allows GM to optimize battery performance and reduce costs while focusing on sustainability.
Similar to BYD's Blade battery initiative, GM's investment in battery technology reflects a strategic pivot towards enhancing safety, efficiency, and performance in the rapidly evolving EV market.
Future outlook: predictions for BYD's Blade battery technology by 2024. As BYD prepares to roll out its Blade battery technology by 2024, several predictions can be made regarding the impact and evolution of this innovation in the electric vehicle EV market.
The integration of this technology is poised not only to enhance BYD's market position but also to influence broader industry trends.
Here are key predictions for the future. 1. Market leadership and competitive edge.
BYD's significant $1.2 billion investment in R&D will likely fortify its status as a leader in battery technology. By prioritizing safety, efficiency, and performance, BYD is expected to capture a notable market share, particularly among safety-conscious consumers.
The successful launch of the Han EV with Blade battery technology could serve as a benchmark,
prompting competitors to elevate their safety standards or risk losing market relevance. 2. Increased adoption of safety-centric technologies. The Blade battery's advancements in safety, such as its performance during nail penetration tests, will likely drive a shift in industry focus from merely maximizing energy density to ensuring comprehensive safety protocols. This trend might compel other manufacturers to invest in similar safety innovations to avoid potential liabilities and reputational damage. As consumers become more informed, demand for safer battery technologies is anticipated to grow, further propelling BYD's Blade battery into the spotlight. 3. Collaborative industry partnerships. BYD's openness to collaborate with other vehicle brands will foster a more integrated approach to battery technology across the EV industry. These partnerships could lead to shared innovations and standardization of safety measures, potentially establishing a new norm for battery manufacturing. As BYD engages with global partners, the Blade battery could become a reference point for safety standards in EV manufacturing. 4. Expansion of manufacturing capabilities. The planned construction of new manufacturing facilities in central China will likely enable BYD to scale production rapidly. As demand for EVs continues to surge, the ability to produce Blade batteries at scale will position BYD to not only meet its internal needs but also fulfill orders from external partners. This expansion could result in increased job creation and contribute to the local economy, further solidifying BYD's role in the EV ecosystem. 5. Technological evolution and innovations. As BYD continues to invest in R&D, the Blade battery technology is expected to evolve. Future iterations may introduce enhancements in energy density while maintaining safety as a core attribute. This balance could lead to breakthroughs in battery chemistry and design, further pushing the boundaries of what is currently achievable in EV performance. BYD might also explore recycling and second life applications for used Blade batteries, contributing to sustainability efforts in the industry. 6. Regulatory impact and industry standards. As more automakers adopt similar technologies, regulatory bodies may respond by establishing stricter safety standards for EV batteries. BYD, with its emphasis on safety, could influence these regulations, advocating for industry-wide adoption of best practices. This could lead to a shift in compliance requirements that prioritize battery safety, ultimately benefiting consumers and manufacturers alike. 7. Consumer perception and market dynamics. The introduction of the Blade battery could reshape consumer perceptions of electric vehicles. As safety becomes a prominent feature in marketing strategies, consumers may view EVs equipped with Blade batteries as more reliable and attractive options. This shift in perception could drive increased sales and market penetration of BYD's vehicles, as well as those of partners that adopt the technology. 8. Long-term environmental benefits. The Blade battery is designed to reduce the likelihood of thermal runaway and related incidents, which can have severe environmental implications. As the EV market expands, the adoption of safer battery technologies like BYD's could lead to fewer catastrophic failures and environmental hazards. This development aligns with global sustainability goals and could enhance the overall environmental footprint of electric mobility. 9. Global market expansion. With the Blade battery technology, BYD is likely to expand its footprint beyond China, tapping into markets in Europe, North America, and other regions where EV adoption is accelerating. The company's commitment to safety and efficiency could resonate well in markets that prioritize these features, potentially leading to increased exports and international partnerships. Conclusion. The implementation of BYD's Blade battery technology by 2024 is set to revolutionize the electric vehicle landscape. Through strategic investments in R&D, a focus on safety, and collaborative partnerships, BYD is poised to lead the charge in redefining industry standards. As the company navigates through critical phases of development, the implications of its innovations will ripple across the EV market, shaping consumer expectations and influencing global battery technology standards for years to come.